Hello, my name is Chris Knoll with Janssen Research and Development, and in this video, I'm going to be describing designing cohort definitions in Atlas. So as a reminder, a cohort is a set of persons who satisfy one or more inclusion criteria for a duration of time. The questions we ask when designing a cohort are, what events let you enter a cohort? What inclusion criteria are applied to those events? For each event, how long do you satisfy the inclusion criteria? And how should events be combined into cohort eras? So let's look at the elements of a cohort definition with respect to the previous questions and within the context of a person's observation period. For cohort entry, we identify the events from person-level time-stamped observations by querying the CDM by domain, concept set, and any domain-specific attributes. Initial events can be further qualified for cohort entry through the use of inclusion criteria. We can require the presence or absence of other patient-level observations relative to the initial event. Atlas can provide reports on the inclusion criteria to evaluate the impact of these rules. For those qualified events, the cohort definition specifies the rules for how long the event will maintain membership in the cohort. There are several options from until end of the observation period to a fixed number of days. The cohort errors are constructed from the qualified events, and a person may have many errors within a cohort. So the cohort definition tool in Atlas provides the functionality to query the CDM and apply temporal logic to the events. Basic functions are concept sets, which specifies the codes that represent a clinical idea, a query to find records in the CDM tables using concept sets, count, which counts the records from a query relative to an index record's start or end date, and groups, which performs and/or operations on counts. To define a cohort, we use 4 steps. These steps will use queries, counts, and group functions to facilitate those operations. The first step is cohort entry events. In this step, we query the CDM for records that signal the entry into the cohort. These are the observational data found in the CDM domain tables, and multiple queries can use events from different CDM domains. In this example, I'm showing a cohort entry event where there are 2 queries, one for condition occurrences of Crohn's and another for drug exposures to treatments of Crohn's disease. In step 2, we apply inclusion criteria. This applies temporal logic to events from step 1, such as have at least 1 procedure occurrence of colonoscopy within 30 days, or at least 1 observation of biopsy within 30 days. So in this screenshot of the UI, we can see 1 group, and within this group, we have 2 count expressions. The first count expression is asking for at least 1 occurrence of a procedure of colonoscopy within 30 days before and 0 days before the index start date. And the second is looking for at least 1 occurrence of biopsy, where the event starts between 30 days before and 0 days before the index. By default, a person remains in the cohort for the remainder of their observation period. Using a fixed duration, you can specify that each entry event persists for a specified number of days. So in this example, we're showing that we are going to persist this event from the start date to 30 days after the start date. The second option for specifying cohort exit is using a continuous exposure, where you can specify that each entry event persists until an active exposure ends. So this UI shows that you select a concept set and then specify additional parameters that will govern how these exposures are determined to be continuous. Note, this isn't a query, but a specialized form designed to find drug exposure records for a given concept set, allowing the user to override the drug exposure end date and specify the persistence and surveillance windows for building the continuous exposure. When the continuous exposure ends, the person leaves the cohort. The third option for cohort exit is using sensor events. Sensor events use a query to identify events that would signal a person's exit a cohort. In this example, I'm specifying that a death occurrence will exit the cohort. You are able to use multiple queries to find different kinds of censoring events that would signal the person should exit the cohort. The fourth and final step is constructing cohort eras. Once the cohort events are identified with their start and end dates, overlapping periods of time need to be collapsed into continuous cohort episodes. In addition, this step allows the specification of a gap that will combine events together if they were in the specified gap days. So taking this example where we have cohort events before creating the errors, we can see that there are several event episodes that are overlapping and close proximity to each other. If we have a gap of 0 days, then only the overlapping episodes or events will be combined into these gap errors. So in this case, in these cohort errors. So in this case, we see that we have 5 errors that were created from these individual cohort events. However, if we specify that we want a cohort gap error of 7 days, then any of these episodes that are within 7 days get combined into a continuous period of time or era. So in this case, with 7 days, we've combined these 3 individual episodes into one long episode. And these 2 individual episodes out here were combined into one episode. So let's put these steps together in a real concrete example. We want to identify the periods of time where Crohn's patients are complaining of abdominal pain. Visits where the patient has a finding of pain will be used as cohort entry events, and we will consider visits that are separated by more than 7 days to be new episodes of pain. So step 1 cohort entry events will be the visits. Our step 2 inclusion criteria will be pain during a visit and prior Crohn's diagnosis. Step 3 will be our cohort exit of a fixed offset, which will be 0 days from the visit end date. And step 4, we will define these cohort errors have a 7-day gap or allow for a 7-day gap. By step 3, we have identified the following cohort events for visits. So we can see at day 0, day 3, and day 5, we have these visits, and we have a series of visits where they are Crohn's patients with pain. When we set the event to 7 days, this combines these individual visits into longer episodes. So now these 3 visits were combined into one episode, these 3 were in a second, and these 2 were in the third. The final episodes are Crohn's patients experiencing abdominal pain. So now that you're armed with a cohort definition, you can now see how this cohort definition follows a life cycle for use in Odyssey Standard Analytics. You define your cohort definition in Atlas. That gets saved to a cohort definition structure JSON file. That gets converted into SQL, which is executed on an OMOP CDM, which then populates a cohort table, which feeds into the Odyssey Standard Analytics. There are a couple common questions that come up when people are first working with cohort definitions in Atlas. And the first question involves continuous observation. They ask, what is continuous observation? And what does this mean with continuous observation of at least 365 days before and 0 days after event index date? So first, we should define what continuous observation means. Continuous observation is the period of time between an observation period start and an observation period end. A period of continuous observation can only be defined within a single observation period. So in this example, we have a person with 2 observation periods, and all the time within the first observation period is considered continuous, and all the time within the second observation period is considered continuous observation. However, this gap, day 750 to day 1050, is non-continuous observation because this period of time is broken between the 2 observation periods. So getting back to the statement, with continuous observation of at least 365 days before and 0 days after the index event date, we can see that if we have a person, and these are the these are the events that were returned from a query, the diamonds that are red represent those events that will not be used because they do not have 365 days of continuous observation before. Only once you get to day 365 will the events be used, and these do have the required prior observation. Likewise, in the second observation period, this event is discarded because it's within the first 365 days of this observation period. Only the second event is going to be used. The second common question relates to limits. So what does it mean to limit what does it mean to limit to earliest event per person or limit to all events per person? And why is it possible to specify this multiple times? So if you recall from cohort steps 1 and 2, cohort entry and inclusion criteria provide 2 opportunities to limit events to all or earliest per person. Depending on the cohort design, it may be required that only the first cohort entry event that satisfies continuous observation requirements be used for cohort entry. Alternatively, all cohort entry events may be used, but only the earliest event after inclusion rules are applied should be used for the cohort episodes. So in this example, I've highlighted the elements in the Atlas UI where you can specify limit initial events. If you specify earliest event in cohort entry events, then only the one event that meets the prior observation, continuous observation requirements will be used in the inclusion criteria. Conversely, if you specified all, then multiple events could be sent into the inclusion criteria step. And then here we could specify earliest event so that the earliest qualifying cohort entry event is used for the entire cohort. Note, selecting the earliest followed by selecting all will only result in the earliest. Once you select the earliest per person, all subsequent steps of cohort generation will only use the single event. In other words, specifying earliest in the first step and then all in the second step will not let you have all events used by the person. By specifying earliest in the first step, you've limited to 1 event per person for the remainder of the cohort definition. So in conclusion, cohort designs follow 4 steps: cohort entry, inclusion criteria, cohort exit, and cohort eras. There are several options to define the cohort exit beyond the default of persisting in the cohort until the end of observation. We have fixed duration, continuous exposure, and censoring events. Based on the phenotype requirements, the continuous observation and earliest event selection may be specified in the design. And finally, it's good practice to draw a diagram that represents the parts of your cohort design before trying to enter the information into the tools. So get into the habit of drawing your timeline, determining where the cohort entry may appear, and then what events are you going to look around that entry event for purposes of including that person into the cohort. Once you do that, determine how long do you want this person to exist in the cohort. And all these elements, if you draw it out, it will make using the tools much easier once you know the goal that you're trying to accomplish. And thank you for watching, and I look forward to doing the next set of videos in the future.